Foundation level. Objective 5.1.4 K3. Use estimation techniques to calculate the required test effort. Expect some calculations in the exam under this objective. First question, this is a 3-point estimation technique question. The formulas for this technique are the final estimate E equals optimistic O plus, most likely M multiplied by 4 plus, pessimistic P all divided by 6, standard deviation SD, das P O all divided by 6. In our question, M equals 11, O equals 2, and P equals 14. E equals O plus 4 multiplied by M plus P divided by 6 equals 10. Correct answer is D. Second question, your team uses planning poker to estimate the test effort for a newly required feature. There is a rule in your team that if there is no time to reach full agreement and the variation in the results is small, applying rules like accept the number with the most votes can be applied. After 2 rounds, the consensus was not reached, so the third round was initiated. You can see the test estimation results in the table below. Which of the following is the best example of the next step? Don't panic if you have never seen such a table before and you won't find it anywhere. It's not a standard table. Just take a good look at it and try to figure out what it is about. We have 3 rounds of playing poker. Each round is represented by 1 row in the table. There are 7 members in the team and each one of them has a new estimate each round. The most important sentence in the question is accept the number with the most votes. Forget the first 2 rounds and just consider the last round, round 3. You can see that 13 has the most votes, so we should accept 13 as the final estimate. Let's see what our options are. A. The product owner has to step in and make a final decision. This goes against the mentioned rule of accepting the most votes. B. Accept 13 as the final test estimate as this has most of the votes. Yes, this goes along with our rule. C. No further action is needed. Consensus has been reached. Incorrect. Consensus means all the votes are the same. Consensus has not been reached. The votes in the final round are not the same. Some say 13 and some say 8. D. Remove the new feature from the current release because consensus has not been reached. This is a very bad option to consider. A feature should not be removed because the team cannot agree on the test estimates. We might end up removing all the features then. Third question. You want to estimate the test effort for the new project using estimation based on ratios. You calculate the test to development effort ratio using average data for both development effort and test effort from 4 historical projects similar to the new one. The table shows this historical data. The estimated development effort for the new project is $800,000. What is your estimate of the test effort in this project? This is an example of estimation based on ratios. You will not find the same scenario in similar questions. They will give you a different scenario and ask you to find the ratio in this specific scenario. So don't panic if you see a scenario that you haven't seen before. We have the data of 4 projects. We need to get the average development test ratio. We add all the development efforts and divide it by 4 to get the average. The total development effort is $3,600,000 and the average is $900,000. Same thing for the testing effort. The total testing effort is $360,000 and the average is $90,000. The ratio of the development effort to the test effort is 9 million divided by 90,000 equals 10. So if the development effort in the new is 800,000, then the expected testing effort will cost 800,000 divided by 10 equals 80,000. Which maps to option B? Fourth question. Again, don't panic when you see graphs or tables you haven't seen before. Just try to understand the given scenario and things will be pretty easy. At the beginning of each iteration, the team estimates the amount of work in person days they will need to complete during the iteration. Let E of n be the estimated amount of work for iteration n, and let A of n be the actual amount of work done in iteration n. From the third iteration, the team uses the following estimation model based on extrapolation and then a strange equation. The graph shows the estimated and actual amount of work for the first 4 iterations. What is the estimated amount of work for iteration number 5? This is an example of an extrapolation estimation technique where the effort required for the remaining work can be approximated by extrapolating this data, usually by applying a mathematical model. According to the equation, the estimate of iteration 5, where n equals 5, should be 3 multiplied by the actual effort of iteration, 4 n minus 1, plus the actual effort of iteration 3 n minus 2, all divided by 4. This means we give extra weight to the actual effort of the previous iteration. The actual effort is the light gray bar for each iteration. So the effort of iteration 5 equals 3 multiplied by 6 plus 8 equals 26, divided by 4 equals 6.5, which makes option C the correct answer. Last question. Looks like another 3-point estimation technique question. We have the best case scenario, worst case scenario, and the most likely scenario estimates. The final estimate is 1 plus 3 multiplied by 4 plus 8, all divided by 6 equals 3.5. Okay, but don't fall into the trap of quickly picking option B as your final answer. The scenario of the question says, the following measures of the effort used to execute a single test case, and the question is, what is the final estimate of the time needed to execute all 4 test cases? Ouch, we all could fall for that one. So, we need to multiply 3.5 by 4 and the final answer is 14, which is option A.